Hi, it's Miss Marsden. I'm going to take you through this week's lesson again. First things first, in your booklet, which you should have open, there's a fluency test. And based on what I've looked at from fluency tests which have been sent over to me, I've put a few hints at the bottom which should help you out with being able to answer the full thing. So give it your best shot, pause the video for as long as you need to, and please do use the hints below and your feedback from previous weeks to help you answer the questions. So, independent variables, what you change. Be specific, say concentration of hydrochloric acid. Dependent variables, what you're measuring, which is the rate of reaction. You could say the reaction with magnesium. So suitable range and interval, we're talking about acid. So you have different concentrations. So you can just give a suitable range. And my example is going from the smallest, which is 0.5, up to 2.5. You could have had anything from like 0.1 to 3 if you wish, that's fine too. My interval is 0.5, so that just means I'm going up every 0.5. How could you measure a rate of reaction? Basically, how long does it take for the magnesium to stop bubbling? Or if you want to be really specific and you do have the equipment, you could collect the volume of gas, but we've never done that in school because we don't have the equipment. What am I going to control? What am I going to keep the same? Temperature of the acid, volume of the acid, mass of the magnesium. Could have also had the I don't know what else I could put for that one actually. Just stick to those three. So drawing and labelling the equipment, if you don't draw it on a piece of paper, that's fine. You can leave that one blank because I know it is difficult when you're using a computer. So a hazard is what is causing the risk. So it's the acid that causes the risk. The risk is it could get into your eyes and it could irritate your eyes. A precaution you need to take is to wear goggles. And the table's really straightforward. You just need the independent variable on the left, which is the concentration. Don't forget your units. And then on the right, you just need your dependent variable. So if you said rate of reaction, fine. If you said time taken for magnesium to stop bubbling, fine. It's just your dependent variable. Please use units, for example, seconds. So make sure you've improved each one of those. You give yourself a mark out of 8. So last week we talked about quadrats, and we're going to improve your knowledge on quadrats by practicing some exam question skills. We're also going to develop our knowledge further by talking about percentage cover, and then we're going to talk about how we can use quadrats in something called a transect line. So now questions linking to the content that we've covered so far in the topic. So pause it for as long as you need to answer these questions. Like I say, just either answer them on a piece of paper, or if you've got the booklet open, answer them in there as well. We're going to improve them on the next slide. So different colour pen if you're working on paper, or change the colour of your font. You can see where you've improved. Last week we were talking about quadrats and we talked about using 10. That's a good number to be able to get some accurate results. How can we make sure it's random? You could use a random number generator. You can pick numbers out of a hat, for example. You place them randomly to remove bias. For example, if it wasn't random, you could easily place biotic factors or living factors for number 4, so choose any of those. And number 5, abiotic and non-living factors, and you only need to link it to plants, so choose any of the list below. So last lesson we talked about estimating populations in terms of just counting up the number of individuals within a quadrat, but another way that you can do it is something called percentage cover. So if you're talking about population of grass, for example, it'd be really difficult to count each bit of grass effectively. So what you can do instead is you can work out the percentage cover, and it would save you a lot of time instead of counting the number of sprigs of grass, the number of clovers in a given area. So you use the same method as we talked about last week. So you place the quadrats, but what you do instead is you place them next to each other, and you only count squares where more than half is covered by the grass or the clovers, for example. What you then do is you divide by the total number of squares, and then you times it by 100 to give a percentage. So for example, I've got some flowers here. What we need to do is to calculate the percentage cover of those flowers. So I've placed the quadrats next to each other, like I said. So how many quadrats have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 quadrats next to each other. But I'm only going to count 9 of those because there's only 9 where more than 50% is covered by the plant. So what I need to do, I've got 9 covered. I divide that by the total, which is 25, and then I times that value by 100. So I know that 36% of my area is covered by that plant. So it's the numbers covered in terms of is more than 50% covered by that plant. Divide it by the total number, which is 25 in this instance. And then you times it by 100 because we're talking about a percentage. So what I'm doing now is we're linking this back to last week. So this is a practice of what we did last week. So it says bluebells grow better in shady woodland areas than in full sun. So what I'd like you to do is, using the keywords, I'd like you to tell me how we're going to measure the population of bluebells in the area. So because bluebells are easy to count, what I'd like you to do is, using the counting method we talked about last week, not percentage cover, I'd like you to tell me how we're going to count, how we're going to estimate the population of bluebells. So I've given you the first sentence. I've said measure the area of the sample site in the woodland. What are you going to do next? So I want 5 bullet points telling me how are you going to estimate the population of bluebells in the woodland. The first one was done for you. You measure the area of your sample site. So use a tape measure, and we're going to say maybe that it's 50 metres by 10 metres. So that would give me my area, because I times length times width, so I do 50 times 10, and that would give me 500 metres squared that I'm measuring. So I need to use a grid and random number generators. So basically you make some coordinates, and you generate randomly your coordinates to place your quadrat on, and then you calculate the number of individuals within the squares. So repeat that 10 times, and then you work out a mean by adding them all together and dividing by the number that you have, which is 10. And that will give you your estimate of your population of bluebells. So we're going to keep practicing these because it is just a skill to be able to know what are they looking for. So what you can then do is then repeat the method, because we've just done that in a woodland, which is going to be a shady area. You can repeat it again in a sunny field, for example, where there's no cover. To improve your answer, if you need to copy mine out in a different colour pen, please do, and highlight the key points that you need. So for example, just say first bullet point area, second bullet point grid. So what you can do is you can look back at it, and it's going to help you have a plan for what you need to include. There's some exam questions in your booklet which are linking to quadrats and percentage cover. What you can do is pause the video, and if you need to, rewind it to re-listen to any of it, including the example of how to calculate percentage cover. and that'll help you out as well. We're going to go through these on the next slides. Please don't worry if you struggle with any. So what you need to do is make sure you're talking about random choosing of places to avoid bias. So you're talking about random number generators, coordinates, picking numbers out of a hat. Rest of them are really straightforward. So we've talked about basics in terms of comparing two areas like we just did where we were comparing the woodland to the open field. A different type of question can talk to you about testing a hypothesis. So that's where you need to compare two or more places with changing biotic or abiotic factors. So for example, our hypothesis would be more bluebells grow in a woodland than in full sunlight. You could also talk about another abiotic factor being the pH of the soil. You can say bluebell plants grow better in neutral soil than acidic soil. So all you need to do, the difference is you need to be able to say how you're going to measure the biotic or abiotic factor. For example, if we're talking about pH, I'd say how I would measure that, and I'd say I'd use a pH probe in the soil. If I was talking about light levels, I need to say how I'm going to measure that. I'd say I'd use a light meter. That's the only difference with these questions. You just need to be specific and say how are you going to test the factor which you think is impacting the number of individuals. So my example here, we're going to stick with the neutral and acidic soil. So I'll find a field with neutral soil, but how am I going to do that? I'm going to use a pH meter. And then same thing, I'm going to measure the size of the field and calculate the area. I'm going to do the same thing. I'm going to use my random number generator to choose 10 random coordinates, and I'm going to repeat 10 times. I count the individuals, I calculate a mean, and then I repeat it for a field with acidic soil. Then I compare the means. So I'd use my pH meter, I'd look for a lower pH, I'd repeat it, and I'd compare my results. If we think that bluebell plants grow better in neutral soil, you'd expect to find a higher mean number of bluebell plants in the first neutral field compared to the more acidic one. So just to conclude that when you're testing a hypothesis, you just need to say how you're testing it in terms of the biotic or abiotic factor. What you can do if you're not feeling that confident or if you want to test yourself is do the same thing, but talk about bluebell plants growing better in a light area. So for example, a field compared to a shady area, for example, a woodland. That's percentage cover. What we're going to move on to is talking about something called a transect line. And I've got a very basic diagram of a transect line on the slide now, and I'm going to talk about what that is. So it's a line using to investigate the effect of a change in factor. So we're still talking about biotic and abiotic factors, but we talk about it over a given distance. For example, in relation to where the lake is. So further away or closer to the lake, for example. So you take quadrant readings along the line at various points, at various distances from the factor you're talking about. Again, for example, the lake. So the white squares on my diagram are the quadrats, and they're randomly located based on the sample. So you might use a random number generator to place them. The line that I've got, which is the black line, is called the transect line. And you take random multiple readings, and that ensures you've got data which is free from bias. So you're still not picking and choosing where you place it to support your hypotheses. So you can just basically use them to see how you get different numbers of species. at different places in a specific area. So all you need to do, for example, if you're looking at the number of species closer to water, you'd place a transect line and then you'd have your quadrat every metre, and you can compare the quadrats further away in terms of the number of individuals in there to closer to the lake, for example. So what you can do now is watch the video. I've linked this on this week's instructions as well. And this gives you a specific method for how to use a transect line. So we're going to talk about testing our hypotheses again. And our hypothesis is lichen, which is like a moss, and they grow better further away from a road. So what I'm going to do, I'm going to place a transect line. It's going to start at the road, and I'm going to place a quadrat at regular intervals marked on there. I'm going to say every 2 metres. Every 2 metres that I place that quadrat along the transect line, I'm going to count the number of individual lichens in there. And that's going to give me results which I can put in a kite diagram like we talked about a couple of lessons ago. So what you can see, because remember that the broader the kite, so the thicker it is, the more individuals there are. So at 0, which is basically on the road, there's barely any lichens, if any. And then the further away you get, the thicker the lines tend to be. So what you can do, you can conclude your hypothesis, supporting it saying more lichens grow further away from the road. You then need to give specific examples, saying at 2 metres away from the road, you only find lichen species 3, whereas 10 metres away from the road, you find 5 species of lichen. You're going to get a lot of data to do with transects and quadrats, so you just need to have a basic understanding of this, which you should have from maths anyway. So the mean is the number of individuals, you add them all together and you divide by the number that you have, but you don't remove any anomalies. Median we know is you put it into order and it's the middle number. The mode appears the most often. So what I'd like you to do is, there's a data sheet. I'd like you to answer the questions. Pause it for as long as you need to, and if you need to go back to find your definitions of mean, median and mode, please do. So there's your answers to sampling along the transect line. So the further away from the trees, the more dandelions there are. And you should have written a method down as well. If there's any points that you missed, please add them. The only thing to bear in mind for the table is that because there's no using decimal places, because you can't have 0.4 of a dandelion, for example, you just round it up or down. So if you use decimal places, can you please correct it and write an explanation as to why, just like I have? So the further away from the trees, the more dandelions you have, and then give specific examples from the data. So that's your description for question 6. And then for question 7, you need to explain why. It's because the further away from trees, the dandelions are going to get more light, more photosynthesis, more glucose, more growth. You can also link that to the water and minerals in the soil as well. So mark and improve that. For example, if you didn't talk about the minerals and water as well, please add it, because it's showing a wider understanding of the factors which increase or decrease plant growth. So this is an optional extension task. Everybody doesn't have to do it, but if you want to stretch yourself, you want to demonstrate that you've really understood the content of today's lesson, have a go at the extension questions. Please remember to send your work over to your class teachers, and if you have any questions, please pop them in an email to your class teacher as well, and I know that they'd be happy to help. Remember to complete your Educate quiz for this content by Monday at 8 AM as well.